So you might be wondering why I went off into permutations and combinations in the probability playlist, and I think you'll learn in this video. So let's say I want to figure out the probability. Let's say I'm going to flip a coin 8 times, and it's a fair coin. And I want to figure out the probability of getting exactly 3 out of 8 heads. So I say 8 heads, but 3 of my flips are going to be heads, and the rest are going to be tails. So how do I think about that? Well, let's go back to one of the early definitions we use for probability, and that says it's the probability of anything happening is the probability of the number of equally probable events in which what we're stating is true. So in which the number of events, I guess trials or situations in which we get 3 heads. And exactly 3 heads. We're not saying greater than 3 heads. So 4 heads won't count, and 2 heads won't count. 5 heads won't. Only 3 heads. And then over the total number of equally probable trials. So total number, not trials. Total number of equally possible outcomes. I should be using the word outcomes. So just with the word outcomes, it should be the total number of outcomes in which what we're saying happens. So we get 3 heads over the total possible outcomes. So let's do the bottom part first. What are the total possible outcomes if I'm flipping a fair coin 8 times? Well, the first time I flip it, I either get heads or tails. So I get 2 outcomes. And then when I flip it again, I get 2 more outcomes for the second one. And then, how many total outcomes? Well, that's 2 times 2, because I got 2 in the first, 2 in the second flip. And then essentially we multiply 2 times the number of flips, right? So that's 5, 6, 7, 8, and that equals 2 to the 8th. So the number of outcomes is just going to be 2 to the total number of flips. And hopefully that makes sense to you. If not, you might want to rewatch some of the earlier videos. But that's the easy part. So there's 2 to the 8th possible outcomes when you flip a fair coin 8 times. So how many of those outcomes are going to result in exactly 3 heads? Let's think of it this way. Let's give a name to each of our flips. Let's give a name to them. So let me make a little column. We'll call these the flips. This is my flips column. And I don't know, I could name them anything. I could name them Larry, Curly, Moe. I could name them I would need 5 more names for them, but I could name them the 7 dwarves, or the 8 dwarves, really, because I have 8 flips. But I could, I'll number the flips. Flips 1, 2, 3, 4, 5, 6, 7, 8. And I'm the god of probability. And essentially, I need to just pick 3 of these flips that are going to result in heads. So another way to think about it is, these could be 8 people. And I could pick which of these, how many ways can I pick 3 of these people to put into the car? Or how many ways can I pick 3 of these people to sit in chairs? And it doesn't matter the order that I pick them in, right? It doesn't matter if I say the people that are going to get in the car are going to be people 1, 2, and 3, or if I say 3, 2, and 1, or if I say 2, 3, and 1. Those are all the same combination, right? So similarly, if I'm just picking flips and I have to say, okay, 3 of these flips are going to get into the heads car, or are going to sit on, heads is like they're people sitting down. I don't want to confuse you too much, but essentially I'm just going to choose 3 things out of the 8. So I'm essentially just saying, how many combinations can I get where I pick 3 out of these 8? And so that should immediately ring a bell that we're essentially saying out of 8 things, 8 we're going to choose 3. And that's how many combinations of 3 can we pick of 8, and that's we went over in the last video. And let's do it with the formula first. So let me write the formula up here just so you remember it, but I also want to give you the intuition again for the formula. So in general we said n choose k, that is equal to n factorial over k factorial times n minus k factorial. So in this situation, that would equal 8 factorial over 3 factorial times what? 8 minus k times 5 factorial. Or another way of writing this would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over, I'll just write 3 factorial for a second, then times 5 times 4 times 3 times 2 times 1. And of course, that and that cancel out, and all you're left with is 8 times 7 times 6 over 3 factorial. And I did this for a reason, because I want you to re-get the intuition for, at least for this part of the formula. That's essentially just saying, how many permutations can I, how many ways can I pick 3 things out of 8? And that's essentially saying, well, before I pick anything, I can pick 1 of 8. Then I have 7 left to pick from for the second spot, and then I have 6 left to pick for the third spot, right? And so that's essentially the number of permutations. But since we don't care, if we picked it, what order we picked them in, we need to divide by the number of ways we can rearrange 3 things, and that's where the 3 factorial comes from. And so we're just, hopefully I didn't confuse you, but if I did, you can go back to this formula for the binomial coefficient, but it's good to have the intuition. And then, well, once we're at this point, we can just calculate this. Well, what's this? This is 8 times 7 times 6 over 3 factorial is 3 times 2 times 1, so that's 6. So 6 cancels out, so it's 8 times 7. So there's 8 times 7, or what is that? 56? Right, 56. Yeah, that's equal to 56. So there's 56 different ways to pick 3 things out of 8. Or if I have 8 people, there's 56 ways of picking 3 people to sit in the car, or however you want to view it. But if I have 8 flips, there's 56 ways of picking 3 of those flips to be heads. So let's go to our original probability problem. What is the probability that I get 3 out of 8 heads? Well, it's the probability. It's the number of ways I can pick 3 out of those 8, so it equals 56, over the total number of outcomes, right? The total number of outcomes is 2 to the 8th. Another way I could write that, 56, let me unseparate. That's 8 times 7. 8 times 7 over 2 to the 8th. 8 is 2 to the 3rd, right? Let me erase some of this. Not with that color. Let me erase that. Let me erase all of this just so I have space. And I will switch colors for variety. Let me use the small pen. Okay, so I'm back. All right, so 8 is the same thing as 2 to the 3rd times 7. This is all just mathematical simplification, but it's useful, over 2 to the 8th. And so if we just divide both sides, but the numerator and the denominator by 2 to the 3rd, this becomes 1. This becomes 2 to the 5th. And so it becomes 7 over 32. Is that right? So it's if I were to pick 3 out of 8, yep, I think that is right. And so what does that turn out to be? Let me get my calculator. I often make careless mistakes. Let's see, my calculator seems to have disappeared. Let me get it back. There it is. Okay. 7 divided by 32 is equal to 0.21875. Equals 0.21875, which is equal to 21 point, if I were to round roughly, 21.9% chance. So there's a little bit better than 1 in 5 chance that I get exactly 3 out of the 8 flips as heads. Hopefully I didn't confuse you, and now you can apply that to pretty much anything. You could say, well, what is the probability of getting, if I flip a fair coin, of getting exactly 7 out of 8 heads? Or you could say, what's the probability of getting 2 out of 100 heads? And you could use it the exact same way we did this problem. I'll see you in the next video.